its application part. It is used in Fourier series, it is used in Fourier transformation, it is used in Laplace transformation. Many other chapters we use the concept of complex numbers and uh, complex analysis. Okay, so the basic outline of what I will be considering is, the first thing I will discuss the basics of complex numbers. That is your very primary concepts of complex numbers. Then a little bit about complex functions, and especially about analytic functions, complex numbers properties, then complex functions, mainly analytic functions, and here we will discuss CR equations and also harmonic functions, etc. Harmonic functions, etc. And then I will discuss Taylor's and Lorentz series, then concept of residue. From Lorentz series, we will get the concept of residue, and then we will discuss contour integration. So some very tough integrations can be solved using the concept of contour integration, and that we will discuss in great detail every time we get questions from this. And then concept of residue, and we will also discuss here the concept of singularity. Okay, and finally the branch point and branch cut, branch point and branch cut, and integrals, integration involving branch point. So this will be the outline of the syllabus that I am going to discuss in complex analysis. And I like the books for this chapter: Afkin, Krasik, uh, Krasik, and one book I take some questions from is Kasana. So these are the books that I refer for this particular chapter. Okay, but I don't think that you need to uh, go into any of these books, because I will discuss all the concepts required. Only if you want to see little bit plus minus, you can go to those books and you can refer it. Okay, as I have told many times that soft copy is available. I have put it in Google Drive, which is in the description of the group. You can take it from there. Okay, and Afkin is one of the books that you may purchase also if you want, especially the net students, and Krasik is the book that both net and JAM students can purchase. Okay, beautiful books on mathematical physics. Okay, so this is the outline. So This is clear to everyone? The outline is clear?
Yes, sir.
Yes, sir.
Okay. So one by one we will discuss this.
सर जेम स्टूडेंट के लिए सारा कवर करना
आराम से बोलो, ओपन करके बताओ
जेम स्टूडेंट के लिए कितना करना है कवर इसमें से?
कितना नहीं। जैम स्टूडेंट जो है वो जैम स्टूडेंट ही नहीं है, वो जेस्ट स्टूडेंट भी है। वो TIFR भी देंगे, देंगे कि नहीं देंगे? बोलो
सर
शिवम।
Yes,
यस
sir.
सर यस
तो अगर आप सिर्फ जैम मान लो आपका एग्जाम अब जैम है 10 दिन बाद, तो ऑब्वियसली आप सिर्फ और सिर्फ कॉम्प्लेक्स नंबर्स, प्रॉपर्टीज, कॉम्प्लेक्स फंक्शंस, टेलर सीरीज, बस वहां तक आप करके छोड़ दो जैम एग्जाम के लिए। लेकिन अगर आप जेस्ट देख रहे हो तो आपको लास्ट तक करना पड़ेगा। अगर आप TIFR देख रहे हो तो आपको लास्ट तक करना पड़ेगा। ओके ओके so we know that the number system which we have, the number system that we have can be divided broadly into two parts, and one is having real numbers and another is having imaginary numbers, right? Imaginary numbers. So the understanding of real numbers or the feeling of real numbers is very, very old. I mean, I think since the human civilization have come, we know about the real numbers through counting. क्योंकि हमें counting की जरूरत पड़ी, we needed the counting, so that evolved into real numbers. For example, abhi bhi the way we write the numbers comes from the counting. For example, 1 means one thing, okay? And the letters actually they evolved during the course of time, but initially they all were made for counting. So like 2 was like this is 2, but in due course of time it evolved and we combined it like this. So that is how the 2 became. 3 was like this, and then it evolved and it became like this became 3. So like this all the numbers have evolved, so they have basically evolved from the counting. So our understanding of the numbers comes from counting. सारे के सारे numbers की जो feeling है that comes from counting. 1 apple, 2 apple, 3 apple. So that counting gives the sense of the numbers. Okay, so real numbers have, you know, positive numbers and negative numbers, right? Even 0 is also there. So we understand everything in terms of counting. Like 1 rupees we understand, 0 rupees we understand, and suppose 1 rupees debt is there on us, so that also we understand in terms of -1, that we have to give it to somebody. Okay, that don't belongs to us. So जैसे आप डेबिट क्रेडिट बैंक में समझते हो ना, पॉजिटिव और नेगेटिव नंबर की हमें पूरी फीलिंग है, उसमें हमें कहीं कोई प्रॉब्लम नहीं है. बट ड्यूरिंग when mathematics was evolving, and I must tell you that जो भी greatest mathematicians के आप नाम जानते हो, they all worked in for number systems, for the evolution of number systems. चाहे वो गॉस हो, चाहे वो आइलर हो, चाहे वो जैकोबी हो, तो ये सारे लोगों ने नंबर्स के ऊपर बहुत ज्यादा काम किया, इंक्लूडिंग रामानुजन, इंक्लूडिंग मैनी अदर्स। ओके, सो इस इवोल्यूशन के टाइम पे दे came across with some equations that needed to be solved. For example, I have equation x minus 2 is equal to 0. Okay, so what is the solution of this equation? X is equal to 2, right? This is the solution of the equation. I have an equation x plus 2 is equal to 0. What is the solution?
-2.
X is equal to minus 2, right? Now I have an equation x square minus 4 is equal to 0. Now what is the solution? X is equal to
+2 and -2.
4, 2 and minus 2. So that means if I square, this will translate into x square is equal to 4, right? X square is equal to 4. So if I square 2, I get 4. If I square minus 2, again I get 4. Yes or no? So squaring 2 will get us 4. Squaring, mic iska on hai, please mic apna off rakho. Whenever you want to ask question, unmute it, ask the question and then again mute it. Okay. So what is the square of 2? It gives us 4. What is the square of minus 2? It again gives us 4. So that's why there are two solutions of x square minus 4. One is plus 2 and another one is minus 2. Now, it was so obvious while solving these equations that somebody will get to this equation x square plus 4 is equal to 0. Now, when you try to write this x square is equal to minus 4, this came as a problem. Now, how to write a number jiska square is a negative number? This came as a problem. And this was encountered by so many mathematicians, great mathematicians, including Gauss, including Euler, everybody encountered this. X square is equal to minus. Now what number to write jiska square minus 4 ho jaye? 2 will not work, minus 2 will not work. So no number on our real axis can, ऐसा कोई नंबर रियल एक्सिस पे है ही नहीं जिसका स्क्वायर -4 हो जाए. So this appeared as something very, very strange to the mathematicians. So that's why later on you will see that they were called imaginary numbers. Okay. Now this problem was handled in a very, I would say, very not a very scientific or very mathematical way, but एक बड़ा ही इसका simple सा solution निकाला गया. And people wrote it like this कि इसमें जो problem वाला part है that is -1, 4 is not having any problem. Yes or no? So
Yes, sir.
this is giving the problem. So they wrote under root of -1 is equal to just a letter. Because this is a number, it should be a constant. So that constant was written as iota, and just being the first letter of imaginary. So because these numbers were real numbers, so English wise they gave a bad name to this imaginary, which many mathematicians later on they don't agree with this word, because this gives a sense of something that does not exist or some ghost or imaginary kind of thing in the imaginations. But ऐसा कुछ भी नहीं है. This number just belong to a different word. We would see later on. So जैसे ही इसको आप iota लिखते हो under root of -1 को, the problem is resolved and we get the roots as 2 times iota and -2 times iota. Right? ये कोई प्रॉब्लम का सॉल्यूशन नहीं है. प्लीज अंडरस्टैंड, दिस इज नो सॉल्यूशन टू द प्रॉब्लम, because our problem was that can I understand under root of negative numbers in terms of some real numbers? So answer is no. We can't write the under root of negative number in terms of real number. अगर हम real number के terms में लिख पाते, if we would have written it in the terms of real number, that number will belong to the real world. So this cannot be written in terms of real numbers, and this under root of -1 was just expressed as this. This is not a solution, it's just an expression. It was just expressed like this. Under root of -1 became iota, and even till today our understanding of numbers, because it comes from counting, imaginary number does not fit into that. I don't know if somebody gives me 2000 iota rupees, what does it mean? Even till today, I don't know. Okay, nobody knows that. But we have not wasted time कि जब हम iota समझेंगे तभी आगे बढ़ेंगे. We are using it in enormous ways. We are using it magnificently. Even though iota को हम real number के term में नहीं समझते, काउंटिंग के टर्म में नहीं समझते, बट हम इसका रियल नंबर से भी ज्यादा यूज कर रहे हैं. दैट आई मस्ट टेल यू. ओके, वी आर यूजिंग इट मोर देन रियल नंबर्स. आई विल टेल यू इन सम टाइम how that is happening. So this expression iota is equal to under root of -1 was something like this, that this is a different class of number which does not belong to the real axis, and they were called as imaginary number. Now Argand realized. यहाँ तक क्लियर है भाई सबको? Any question from this up to this?
Yes, sir.
It is clear up to this?
Yes, sir.
Yes, sir.
Yeah. So I would give full credit to Argand, who realized that these numbers are just behaving like vectors I cap and j cap. Like I cap vector cannot be written in the terms of j cap. तभी तो वो दो अलग अलग वेक्टर्स की जरूरत पड़ती है. I, j, k to represent the Euclidean space. I cap अगर j cap के फॉर्म में लिखा जा सकता, we would not have needed j cap. Yes or no?
Yes, sir.
So because that cannot be written, they are orthogonal. They form basis. Basis मतलब उतने minimum ingredients चाहिए उनको बनाने के लिए. So numbers को भी Argand got the idea from vectors, and he represented the real numbers on x-axis and the imaginary number on y-axis. And immediately the problem was resolved. So he said that any number z can be written as some number x comma y, which is actually x plus iota y, where x and y are element of real number set. This is the representation of a complex number, and it can be represented on a plane where this axis represents the real numbers, this axis represents the imaginary number, and any number having the real component x and imaginary component as y can be represented here. This will be called x comma y. Yes or no? So this is the Argand's representation. Even जो जैम जैसे एग्जाम है उनमें ये भी पूछा जा चुका है कि एक कॉम्प्लेक्स नंबर है 2 - 4 आयोटा, उसको Argand प्लेन में रिप्रेजेंट करो. So I know you all can do that. Okay?
Sir,
Yes.
what is arrogance, sir?
Argand is name. What is your name? Hello?
Sir, Beulah, sir.
Beulah. Suppose you have discovered this, so it will be Beulah's plane.
Okay.
Yes or no?
Some
In the honor we give the names, no?
it's like that plane.
Yeah, it's a plane. It's like XY plane. X-axis represents the real numbers. Y-axis represents the imaginary numbers.
Okay, sir.
Okay.
Yes, sir.
Now we came across a general form of a number z is equal to x plus iota y, and this number was called now complex number. Now you can imagine how much stress this was giving to the mathematician that they named it as complex number. Like if they are trying to understand it, but still it is very, very complicated, right? So they gave a wrong name to it. It is very, very easy to understand them. Once you accept the imaginary axis also to your family, like we have accepted the real axis, just क्योंकि real की feeling है, so experience है, that is more close to us. But that does not mean कि जितनी चीजें दुनिया में exist करती हैं उनके हमें personal experience होना जरूरी है. There are so many things which may not be we may not give feeling to us, but they do exist. Okay. So, but fortunately, all of the quantities, physical quantities, they belong to the real axis. There is no quantity which is complex. Complex is just a representation. I will explain you it in some time. Like there is no quantity having imaginary iota as a coefficient. Energy cannot be imaginary. Momentum cannot be imaginary. Position cannot be imaginary. Okay. So this is, so what we have done is, because this is giving us a chance to represent two quantities together which are orthogonal to each other. ये xy axis कैसे हैं? They are orthogonal. तो अगर मुझे दो ऐसी क्वांटिटीज को रिप्रेजेंट करना है जो कि ऑर्थोगोनल है, yes,
Sir.
so we can represent it by x comma y. This is complex number. If I call the real of z, what will come? X. अब ये कभी मिक्स नहीं होते, like the vectors. वेक्टर अगर तुम लिखते हो 3i कैप प्लस 4j कैप, कभी ये मिक्स होके 7 बन सकता है? नेवर. It will never mix with each other because
No, sir.
this belong to different axes. This belongs to different axes. They are orthogonal. They cannot be represented in the form of one another. So these numbers are also like that. And if I call imaginary, what I will get?
Why?
Y.
So because this is also real, this is also real, हम इसको खूब use करने वाले हैं. We are going to use it in so many ways. So you should understand this much first of all. In physics, we are using its real part, we are using its imaginary part. We are not using iota in any way. Please understand this. This will be always there, but will never be used because we don't understand it in physical way. We don't understand it like counting. Like we understand the counting, we don't understand it like this. Okay. और जैसे
Okay,
ही
sir.
एर्गेन ने इसको प्लेन पे रिप्रेजेंट किया, हाई स्कूल ज्योमेट्री पिक्चर में आ गई. जैसे ही एर्गेन ने इसको इस प्लेन पे डाला, immediately high school geometry that you have learned, coordinate geometry, will come into the picture. You will just make a triangle. You will say this one is x, yes or no? This one is y. You will say x is equal to r cos theta. You will say y is equal to r sin theta. And tan theta is equal to y by x. And r is under root of x square plus y square. This is the immediate consequence of representing x comma y on the argand plane. जैसे ही आपने इसको argand plane पे represent किया, ये सब तो high school, as a high school student आप कर सकते हो. Correct?
Yes, sir.
So this theta, which is tan inverse y by x, is called argument. क्या कहते हैं इसको?
Argument.
Argument. And this r is called modulus. This is called argument and this is called modulus. Now this theta is actually written like this between minus pi to pi. Then it is called principal argument. Principal argument. So normal argument can be represented as principal argument को मैं capital से लिख रहा हूँ. Argument z plus minus 2n pi. Because you can see theta can be rotated n number of times to increase the values. So this one is called principal argument. Its value should be between minus pi to pi. And this is general argument. Its value will be argument plus minus 2n pi. Okay? यहाँ तक clear?
Yes.
So जब principal argument पूछा जाएगा तो we will tell a value which lies between minus pi and pi. For example, can I erase this?
Yes, sir. Yes, sir.
So suppose this is your arrogant plane. And this is a point z which is 1 comma 1 and this is a point of z which is what? Minus 1 comma minus 1.
Yes, one.
So if you see the principal argument for this theta, what will be that? Theta will be tan inverse 1 by 1, which is pi by 4. That is okay because pi by 4 lies between minus pi and pi. So it qualifies for the principal argument. Okay. Now,
Yes,
if
sir.
you write this one, what is the angle? Because this is the initial line, this is the angle. This angle will be greater than pi, yes or no?
Yes.
Yes, sir.
So this will not be taken as principal argument. We will take this one. Are you getting it or not? So this one will be which one? Pi by 2 plus pi by 4. So how much it will become? 3 pi by 4? So it will become minus 3 pi by 4, which is okay to become principal argument. it lies between minus pi and pi. So this is the correct answer. If you would have written this one, pi plus pi by 4, pi plus pi by 4, which is 5 pi by 4. So it is not a principal argument. It is an argument, but it is not a principal argument. So this is something very, very important to understand. If anybody has anything to ask, feel free to ask that. So principal argument वो value है theta की that should lie between minus pi and pi. So this, because I have gone clockwise, so that's why I have taken negative sign. Clockwise जाने की वजह से मैंने negative sign ले लिया है. Because anti-clockwise is positive and clockwise is negative. So this representation argument is clear?
Yes, sir.
जिनको नहीं clear है वो जरूर पूछेंगे,
Okay, sir.
और जिनको clear है वो चाहे ना भी बोलें, but जिनको नहीं clear है they must speak.
Sir, sir, how we write pi by 2 plus pi by 4, sir?
Count it from your high school knowledge. What is this angle?
90, sir. Pi by 2, sir.
Pi by 2. What is this angle?
Pi by 4.
So if I want this angle, what should I do? I should subtract or add?
Add, sir. Okay.
So I've added it.
Okay, sir.
Now you want me to take the LCM to calculate 3 pi by 4?
Okay. Got it, sir.
And why minus sign?
It is in clockwise direction.
It is clockwise. Okay. So now बाकी सारी चीजें मैं कहूंगा कि रिजल्ट, इसीलिए I feel somehow that arrogant should be given lot of credit to what we are using today. Because इसके बाद बहुत सारी चीजें, you know, they are natural. Like you have written x is equal to r cos theta and also y is equal to r sin theta. This you have written. Okay. So it's coming out to be naturally. And also I will discuss here now the origin of Euler's equation. Euler's equation. So we know that e to the power x is, or e to the power theta is 1 plus theta square by 2 factorial plus theta cube by 3 factorial plus dash dash dash. Also, cos of theta is equal to 1 minus theta square by 2 factorial plus theta to the power 4 by 4 factorial minus dash dash dash. These are the series of sine, cosine, and this we already know. Theta cube by 3 factorial plus theta to the power 5 by 5 factorial minus dash dash dash. ये सारी चीजें हम जानते हैं. और अगर मैं by chance if I put for this e to the power iota theta, then what will happen? 1 plus iota theta plus iota theta square by 2 factorial plus dash dash dash, and this will result into 1 minus theta square by 2 factorial plus theta to the power 4 by 4 factorial minus dash dash dash, and plus iota will come out to be common, and it will become iota into, you can see it will become iota into theta minus theta cube by 3 factorial plus theta to the power 5 by 5 factorial minus dash dash dash. This will become e to the power I theta. What is this written here? It is cos theta plus iota, and what is written here is sin theta. This is the one of most powerful equations that is known as Euler's equation.
Sir, I
Okay.
cannot understand the steps. Sir.
Yeah, yeah. Ask what?
Second step, please समझाए
Which step? This step?
हाँ sir, second step.
I theta cube by 3 factorial plus I theta 4 by 4 factorial. Just simple mathematics.
Yes,
1
sir. हाँ sir.
I square is minus 1. It will become minus
हाँ,
theta square by 2 factorial. I
हाँ
to the
sir.
power 4 will become 1.
हाँ
It
sir.
will become theta 4 by 4 factorial and dash
हाँ
dash
sir.
dash.
हाँ sir.
Take iota common. Here you will have theta.
हाँ sir.
Theta cube is minus iota. So it will become
हाँ,
minus theta cube by 3 fact. So I have used this. I square minus 1. I to the power 4 1. I cube is minus iota. And I to the power 5 is plus iota. So all the real quantities you write here, take iota common and again write all the real quantities. So what will come to the first bracket is this, this, and this. And what will come to the second bracket is this one and this one, and here theta to the power 5. I theta to the power 5 by 5 factorial plus dash dash dash. Got it now? Whatever is written in the first bracket is actually cosine series, and whatever is written in the second bracket is actually sine series. And here comes the wonderful equation, and that is called Euler's equation. Please ask if there is any doubt. This is why iota appears. This is the reason why iota appears everywhere in physics. The iota in physics is only because of Euler's equation. So that's why, all the great physicists and mathematicians, they have called this equation as wonderful equation. Somebody has called it a strange equation, including Feynman, including many other big names. Okay. बताओ clear है भैया? Now it's clear. Who asked that? Some network issue or what?
No, sir, it's fine, sir.
Okay. So this is such a wonderful equation, and please remember, we will not use iota anywhere. बस ये साथ में रहेगा हर जगह. As such iota का कोई यूज नहीं करना. Now if you call real of e to the power iota, you get cos of theta, and if you call imaginary of e to the power iota theta, we get sine of theta. So this is how iota enters into physics, because sine and cos theta are part and parcel of physics. Everywhere they appear. So जहां cos theta लिखना होता है, there we write real of e to the power iota theta, और जहां sin theta लिखना होता है, we write imaginary of e to the power I theta. उसके बहुत सारे benefits हैं. So we go into complex space because the calculation is very much easy, because exponential function is very, very easy to handle. Why? Because derivative of exponential is so easy. Even n times derivative is so easy. If you make n times derivative, it's just this. And even integral is so easy. It is just this. So that's why from cos theta and sin theta, we move to complex space. And so many operators are formed, like momentum operator. You get momentum operator because of the complex thing. So in a way, quantum mechanics is also based on this Euler's equation. Without Euler's equation, you can't imagine quantum mechanics. ठीक है भाई? यहाँ तक ठीक है?
Yes, sir.
Yes, sir.
Now, so many things were resolved because of this Euler's equation. And the Feynman called this particular equation astonishing, because it was like this: e to the power iota theta is cos theta plus iota sin theta. Euler's equation. And if I put theta is equal to pi, it will be e to the power iota pi is equal to -1. Because you know that cos of n pi is -1 to the power n, and sine of n pi is equal to 0. Now see this equation. This equation is so strange. It consists of exponential, the fundamental of mathematics, everywhere it appears. It consists of imaginary number, iota. It consists of pi. I don't know from where pi enters into everything. Everything we calculate, pi is there. And it consists of 1, which is a unit, real number. So all these fundamental entities of our calculations are present in a single equation. And this is so astonishing that we don't understand what is iota, at least in terms of real numbers, but there is equal to sign. So right hand side we understand. We understand this, we understand negative, we understand e, we understand pi, but we don't understand iota. So these are the quantities which we understand in our measurement context. Measurement के context में सारी चीजें हमें पता है, but we don't know iota. Equal to का sign है, but in a way we know that means. Okay, so that's why Feynman called it a very, very surprising equation, very, very astonishing equation. It's like connection between imaginary and real world. Real and imaginary words are orthogonal. They can't be written in terms of one another, but still they are related by Euler's equation. Okay? और इसी तरह से you must have seen when we plot log of x versus x. We always plot it like this, right? We always on the positive side of the x-axis for log. Why? Because this is the real plane. This is real plane. Everything on this plane is real. This is a real plane, right?
Yes, sir.
So what is happening that if you go to the left side, that means negative of log, for example, log of -1. So because now we understand this, log of -1 is e to the power iota pi. So this will become just iota pi. So that's why we never go to left hand side, because left hand side will give us imaginary numbers, which we can't plot on this real plane. So log of negative numbers is actually what? Imaginary numbers. Imaginary numbers. And please see this also, log of 1. Why it becomes 0? Log of 1 is log of e to the power iota 0. Yes or no?
Yes, sir.
So this is just what? 0.
Cos 0. Yes, sir.
This is just 0 because 0 will come in the front. Yes. And also log of 0 here is asymptotic towards the negative y-axis. So log of 0 can be written as log of e to the power, or you can just avoid iota here, you can just write e to the power 0. Log of e to the power minus infinity, because e to the power minus infinity is 0. So if I take minus infinity common, it will become log of e. Log of e is 1. So that means it will become minus of infinity. So that's why 0 पे log जो है वो minus infinity की तरफ चला जाता है. See this. So many things just came out of Euler's equation. Yes.
सर एक क्वेश्चन पूछ सकता हूँ क्यूरियोसिटी से सर?
हम्म.
सर आपने ln1 को log1 को log e to the power 0 लिखा है.
हम्म.
क्या जरूरी है कि हम लोग हमेशा प्रिंसिपल वैल्यू ही लें? क्या हम 2 and pi के फॉर्म में नहीं रख सकते हैं इसको?
So ये जो वैल्यू है, यहाँ पे जो वैल्यू log की तुम ले रहे हो, ये सारी प्रिंसिपल वैल्यू ले रहे हो. This is the principal value which you are taking.
Yes, sir.
This is the plot. When you say log 1 is equal to 0, when you say this is at principal value of this. Okay?
Yes, sir.
E to the power, you say it is e to the power iota 0, right? Is equal to 0.
Yes, sir.
So this is the principal value. This 0
Okay,
is the
sir.
principal value. So ये जो plot वगैरह कर रहे हो, ये सब जो value discuss कर रहे हो, this is all principal value.
And sir, like any special reason for
इसका
preferring the principal values?
इसका मतलब कि जो हम डिस्कशन करते हैं, जिसमें हम प्लॉट बनाते हैं, वैल्यूज लेते हैं, दे ऑल आर प्रिंसिपल वैल्यूज.
Yes, sir.
फॉर n इज इक्वल टू 0. ठीक
Yes,
है?
sir. Yes, sir.
तो जो जनरल वैल्यू है, इट इज लाइक दिस ना. आर्ग्यूमेंट z is equal to argument z plus 2n pi. ठीक है? Like this. So we are taking only this value right now in this discussion. argument z, this value. This is the principal value. Because there are other values also. So why we are taking this? Because suppose this is the Argand plane and you have taken only this much rotation.
Yes, sir.
So all values will be principal, right?
Yes, sir.
If you take so many rotation, then only you will get to have other values, right?
Right,
So
sir.
principal value unique bhi hai because you have bounded it between this. So you will write a unique value which only lies between this. So that is kind of characteristic also. Okay.
Okay, sir.
तो यहाँ तक क्लियर है सबको?
Yes, sir.
Yes, sir.
So even so many other things can be done using this Euler's equation. Let me give you one instance. That suppose your electric field is E is equal to E naught cos omega t plus phi. Suppose this is your electric field. Okay. What you can do is just represent it like this: E is equal to E naught e to the power I omega t plus phi. Are you getting it? And do whatever you want to do. Put it in wave equation, refractive index, whatever you want to calculate. Just finally take the real part because it is started from this. So real part of this e to the power iota, this will become cos omega t plus phi. This is how complex enters in our situation. Next example I want to give is, suppose I want to calculate integral of cos theta d theta. Suppose I don't know this integral. So what I will do is I will calculate integral e to the power I theta d theta. And I will just take the real part of this, as I told you. Now this integral is so easy, it will become e to the power iota theta by iota. Just iota you have to treat as a number. This will become real of minus iota cos theta plus sin theta. Yes or no?
Yes, sir.
This is cos theta plus iota sin theta by iota. So real of this will become sin
Sin
theta,
theta.
which is the integral of this. This is how complex enters and we use complex. और इसके साथ अच्छी बात यह है कि if you calculate it for one quantity, if you calculate it for cos, sin already we have calculated. What will be integral sin theta d theta? It will be the imaginary of this, which is minus cos theta. You see, imaginary part of this will be coefficient of iota, that is minus cos theta. So this is how it enters into algebra. This is how it enters into integrals. I am giving you just an example. Obviously, you are not going to solve integral of sine and cos theta like this. Just to give you an example, how that cos theta and sin theta are converted into this. All right. Also, थोड़ा सा मेहनत करी डी मॉर्वियस ने, and he gave a formula that if e to the power I theta is cos theta plus iota sin theta, then you can write e to the power I theta to the power n is equal to e to the power I n theta by simple. And when you open this, it will become cos of n theta plus iota sine of n theta. This is called de Moivre's theorem. So that means if it is e to the power I n theta, it can be written as cos theta plus iota sine theta. The immediate consequence is that if I want to write e to the power minus iota theta, it will become cos theta minus I sine theta. Because of this ASTC. Cos of minus theta will remain cos theta because it will be in fourth quadrant, but sine of minus theta will become minus sine theta because in fourth quadrant. जब आप minus theta लिखोगे, you will come like this. You will enter into fourth quadrant, and their sign is negative. और जैसे ही you got these two equations, you can now write sine and cosine entirely in the form of Euler's equation, because add them, you will have cos theta is equal to 1 upon 2 e to the power I theta plus e to the power minus I theta, and sine theta is equal to 1 by 2 iota e to the power I theta minus e to the power minus I theta. These two equations will be used very, very frequently. By the knowledge of Euler's equation and this concept of real and imaginary part, we can even calculate so many other things. Like, I would also like to introduce here a different class of functions called cyclic functions. The cyclic functions, what are they? अगर मान लो साइन के अंदर आयोटा x आ जाता है, इसको साइक्लिक फंक्शन कहते हैं. How it will be handled? Use this. Theta is equal to iota x. It will become 1 by 2i e to the power. Put it here ix minus e to the power x. Like this. Take iota in the numerator. It will become iota e to the power x minus e to the power minus x upon 2, which is sine of iota x is iota sine hyperbolic x. Similarly, put it for cos of iota x. Put theta is equal to iota x. You will get cos hyperbolic x. So sometimes it will be necessary for us to use this. इसलिए इसको भी आप note कर लो. So basic, and it comes so normally from the basic formula. I was यहाँ तक ठीक है भाई? सबको समझ आ रहा है? अब ये सारी चीजें बाद में यूज होंगी, तो इसलिए अभी अच्छे से समझना है. It's like ABCD of complex numbers. Now अभी एक चीज और देखो कि suppose I want to integrate e to the power ax sin bx dx or e to the power ax cos bx dx. Suppose I want to integrate this. आपने क्लास 12th में किया भी होगा, फर्स्ट फंक्शन सेकंड फंक्शन लेके. But using complex numbers, it becomes so easy. Like I will just put integral e to the power ax e to the power, I will put it like ibx. जब मुझे साइन की जरूरत होगी, I will take the imaginary part. जब I will require cos, I will take the real part. So this will become integral e to the power a plus iota b and x and dx. Now this is such a simple integration. It will become e to the power a plus iota b x upon a plus iota b. A plus iota b is just like a constant. And since I want real and imaginary part, I will rationalize it. I will put it like this. And this, if you multiply, you get e to the power ax over a square plus b square into a plus iota b, a minus iota b. Multiply करके देखो. A square plus b square can be factorized into a plus iota b into a minus iota b. And you will be surprised to know, first time this was done by Gauss himself. You can call him father of mathematics. Gauss factorize this positive thing, and ये इतनी जगह आता है, use होता है. Even contour integration cannot be done without using this fact. And this is so simple that you just write a square minus iota square b square and then use your simple formula of a square minus b square. So this brilliant thing was done by in one of the works of Gauss first time, and then everybody started using it. अब ये देखो जरा, ये मैंने e to the power ax अलग लिख लिया, a square plus b square denominator में. Now if I want this, suppose integral e to the power ax sine of bx dx, so I will take only imaginary part. So from where imaginary part will come? Please see this. This will be a minus iota b and e to the power. So this will be e to the power ax upon a square plus b square a minus ib into cos of bx plus iota sine of bx. Open this. Now take the imaginary part. So first imaginary part will come when a will be multiplied by this. So it will become a sine bx. And second will be when this will be multiplied by this minus b cos bx. So this is the integral that is coming for sine. And the second one is when integral e to the power ax cos of bx dx will become, again I will take now the real part. It will become e to the power ax upon a square plus b square. अब real part लेना जरा यहाँ से, a cos bx, a cos bx
plus b
plus b sin b.
plus b sin bx. So you can see the beautiful integrals that this will be used in everywhere. Fourier series, Fourier transformation, Laplace transformation, quantum mechanics, everywhere these integrals will be used. And they come so simply by complex analysis. Note down this. Ask if any step is not clear. So complex की beauty ये चीज जो है, मैं तो इसको देख के बहुत ज्यादा fascinate होता हूँ कि how beautifully Gauss managed to do factorization of between the positive squares. All steps are clear?
Yes, sir.
Yes, sir.
Tell me if anything is not clear, please.
सर
Hmm.
सर एक बार ये रिवाइज करिए e की पावर x tan x तो मैं रियल में नहीं पता अलग केस से तो डाउट है अभी क्या कर सकते हैं
कहाँ पे?
सर e की पावर a इंटीग्रल e की पावर x sin bx dx से हमने e की पावर x को कॉमन ले लिया और e इसका भी इसका लिया तो समझ में आ गया लेकिन ये e की पावर मैंने इसका इधर जो लिया है e sin bx और b सर नीचे वाली लाइन में जस्ट इसके नीचे ये हाँ ये वाला
तो
ये कुछ समझ नहीं आया।
इमेजिनरी लो ना, खुद मल्टीप्लाई करो। आयोटा वाला पार्ट कहाँ से मिलेगा? सबसे पहले अपना बंद कर दो माइक, तुम्हारा माइक खराब है, फिर वो सबको डिस्टरबेंस होता है। आयोटा ये इमेजिनरी पार्ट है, साइन कहाँ से आएगा? यहाँ पे शो कर दिया मैंने आपको, e टू द पावर आयोटा bx लिख दिया। तो व्हेन आई विल टेक इमेजिनरी पार्ट देखो कैसे मिलेगा। व्हेन a विल बी मल्टीप्लाइड टू दिस, तो सबसे पहले आयोटा आएगा, a इंटू आयोटा साइन bx। इमेजिनरी पार्ट लेना है इसलिए मैंने लिख दिया a साइन bx। ओके, फिर देखो जब आयोटा b मल्टीप्लाई होगा कॉस से, तो यू विल गेट माइनस b कॉस bx। वो यहां लिखा हुआ है माइनस b कॉस bx। बताओ कैलाश।
हाँ सर अब हो गया
और ऐसे रियल पार्ट देखो, a जब cos bx से होगा ये रियल होगा, और जब माइनस आई बी आई से मल्टीप्लाई होगा दैट विल ऑल्सो बिकम रियल। सो वो यहां लिख दिया है। तो 4 आएंगे, 2 here 4 टर्म्स आएंगे, 2 will go to the real one, 2 will go to the imaginary one. Okay?
ओके सर
Any other thing which is not clear to anybody? बताओ भाई, कुछ भी पूछना है तो प्लीज आस्क। So this is how complex analysis is used. Please understand, iota is just there. Like if I represent the impedance in electronics, suppose I write R plus iota xc. What does it mean? So that means you have resistance which are having a phase difference of 90 degree. So suppose this is the resistance and this is the resistance. They are having a phase difference of 90 degree. So we have represented it by this complex because complex numbers are also at 90 degree. Yes or no? So I
Yes,
want to write these things together with a phase difference of 90 degrees. So I can represent it by complex number. Similarly, refractive index are represented. N is equal to N plus, ये दूसरा N है, okay? N tilde कर देता हूँ, N plus iota K. So this is also refractive index, this is also refractive index, but they are having a 90 degree phase difference. They behave differently to the incident wave. The material behaves differently. Like here, the current behaves differently for resistance and this is also resistance. दोनों का unit ohm ही है, but they are behaving differently to resistor and capacitor. So that different behavior is written together in the form of complex number. Okay? That distinct behavior. So those quantities having a phase difference can be represented using complex number. And now the final thing is कि अगर हम किसी तरह से सारे numbers को complex numbers बना दें तो it will become a general family and I can now real numbers and imaginary numbers will be the subset of complex numbers if I can write every number as complex numbers. Yes or no? अगर मैं सारे numbers को complex number के form में लिख दूं तो it will become a general number and every number will be subset of complex number. So for that, I need to write only 1, -1, iota, and minus iota. These 4 numbers in using Euler's equation. अगर मैं इन 4 numbers को लिख दूं तो कोई भी complex number बन जाएगा. Tell me any complex number.
4 minus 3.
Yes, P. Sri Lakshmi. Can you tell
Sir,
any complex number? Tell me. Z is equal to
3 plus 4i.
3 plus
4i.
4 iota. So you can see this number requires 1 into 3 plus 4 into iota. Yes or no? So I have to just take care of 1 and iota. Take any other number. -3 minus 4 iota. So it is -1 into 3 plus 4 into minus iota. So here I want -1 and minus iota. So these are the basic ingredients which if I write, I would be able to write any complex numbers. Right? So let us do that. So let us write the general numbers. First of all, principal value and then all values. So let me write it like this: e to the power iota 0. Is this 1?
Yes, sir.
And then I will add e to the power I 0 plus 2n pi to make it general. So this will become e to the power iota 2n pi, where n is 0, 1, 2, dash, dash, dash. N is equal to 0 value will be called principal value. -1 e to the power iota pi. बताया था मैंने अभी. It will become e to the power iota pi plus 2n pi. This will become e to the power iota 2n plus 1 and pi. And iota is e to the power iota pi by 2, which is e to the power iota pi by 2 plus 2n pi, which is e to the power iota 2n plus half and pi. So I am adding 2n pi to generalize the angle, okay? So that they can now represent every angle on the plane. And this will become e to the power principal value लिखनी है मुझे, तो minus I pi by 2, which is e to the power iota minus pi by 2 plus 2n pi, which is e to the power iota 2n minus half and pi. So these are the values of these numbers so that we can now represent any number in the form of complex number. Please understand this carefully. If there is any doubt, ask.
सर
and
2n ऐड कैसे हुआ?
Sorry,
2n पे जो ऐड किया है ना वो कैसे हुआ सर?
2n pi to make it general angle. Like if you make one rotation, it is 2 pi.
Yes sir.
Then you start taking n is equal to 1 means first rotation. So from
Okay.
any angle, you can make these rotation to get the same angle. Yes or no?
Yes sir.
Like one rotation, then 2 rotation will also give the same angle. 3 rotations will also give the same angle. So I have to represent all the angles. So how to do that? By adding 2n pi.
Okay sir.
Suppose this is the angle pi by 4. But if I take one round, that will be again the same angle, na?
हाँ सर ठीक
So that will be pi by 4 plus 2 pi. Then I will take another round, pi by 4 plus 4 pi. Okay?
हाँ
Like
सर
that. और किसी को कोई डाउट?
सर ये जो -1 इक्वल टू ई टू पावर आयोटा पाई लिखा है ये फॉर्मूला है क्या?
No formula. I told you Euler's equation. E to the power iota theta is cos theta plus I sin theta. E to the power iota pi will be cos pi plus I sin pi. Sin pi is 0. Cos pi is -1. I told you na ki cos of n pi is -1 to the power n. So what will be cos pi? See your copy immediately after Euler's equation. I told this. I will not write anything which I have not taught before. Please understand this. Whatever I write here, I have already told you. You can see in your copy. These all are coming from the Euler's equation. Open this. Cos pi plus I sin pi -1. Cos pi by 2 plus I sin pi by 2 iota. Cos minus pi by 2 plus iota sin minus pi by 2 minus iota. So this all is written using Euler's equation. Is that okay? चलो मैं आगे डिस्कशन इसके आगे करूंगा. अभी किसी को कोई डाउट है तो प्लीज फील फ्री टू आस्क. Otherwise, this is the end of the today's class. Okay, I think it's clear to everyone. You can ask in next class also. But revise whatever I have taught. Okay. Thank you so much.
Okay, sir.
Thank you.
थैंक यू सर.
Thank you, sir.
Thank you. Good night.